Okay, students. So let us begin. So we are studying electromagnetic waves and communication system chapter. Okay. And we have covered a lot of part which includes everything about electromagnetic waves, that is how EM waves are produced and what was the theory that started. Maxwell was the person who predicted that there is something called EM waves, and then Hertz was someone who discovered the presence of EM waves, how EM waves are produced, what exactly are EM waves. Okay. And we have also seen certain characteristics of EM waves, that we have electric field and magnetic field perpendicular to each other, and both of them are perpendicular to the path of propagation. Okay. Then all these properties, that a velocity of EM wave in vacuum is equal to velocity of light. Okay, fine. So all these things we have seen last time. Okay, fine. And we did these three numericals as well. Okay, very simple numericals. And then next part, this theory part that was there over here. Okay, everyone please sit with your textbooks. Okay, and if I ask you all to mark anything, you all are supposed to mark. So this theory part that starts from here. Okay, what was this theory part? It stated that see, we know that in our EM waves, electric field and magnetic field, they vary sinusoidally, that is, they move in a sine wave fashion. All right, fine. So if I consider that my wave is traveling along x-axis, okay, my EM wave is propagating on x-axis, where my E vector, that is electric field, is around y-axis, and my B vector, that is magnetic field, is along z-axis. Okay, so what we have done is we have obtained equations for my electric field, and we have obtained wave equations. Okay, there is a standardized this thing of finding wave equation. All right, fine. So using that standard wave equation, I have obtained equation for my electric field, which is around y-axis, that is why EY, and magnetic field, which is along z-axis, that is why BZ. Okay, but my waves are traveling in sine fashion, yes or no? So these equations I told you all, this is something that they have directly written referring to the standard wave equation that is there. Okay, so now in this particular equation, let me just zoom it in a little bit. Just 1 second. Okay, sure. Yeah. So see, in this equation, EY, E naught sine kx minus omega t. So what is E naught? E naught is nothing but the amplitude of the electric field. Same equation we write for BZ as well, where B naught is the amplitude of magnetic field. Okay. Sine is the sine function. We all know that. X stands for the x-axis because the wave is propagating, the EM wave is propagating along x-axis. Yes or no? What is k over here? K is nothing but the propagation constant, which is given by 2 pi by lambda. Lambda is the wavelength. I hope you all know this. Okay, fine. And t stands for time. And what is omega over here? Omega is the angular frequency, which is given by 2 pi f. Or instead of f, f stands for frequency. So you all can use the notation f, or you all can use this mu notation as well. Okay, fine. So this is actually something that we did last time already. यस, सौरभ इज आस्किंग ई नॉट को ए से डिनोट कर सकते हैं ना? कर सकते हैं, वही स्टैंडर्ड इक्वेशन है. दैट इज व्हाट आई एम टेलिंग. सी स्टूडेंट्स, वेव इक्वेशन, देयर इज अ स्टैंडर्ड इक्वेशन दैट हैज बीन डिराइव्ड. ओके, आई विल शो यू ऑल द इक्वेशन. वेट, आई विल गेट टू दैट पार्ट. सो this is actually a link that I got while I was searching from Google. Okay, so it's a very big page and lot of things are written over here, so we won't concentrate on the extra part and everything. I'll just tell you all what is required. Okay, so you all can see over here, students, there is a sine wave that is propagating. Okay, fine. I hope just 1 second. Yeah, so I hope you all understand the maximum displacement, the peak that is there. It is nothing but the amplitude. So here above the value is +1, this is -1. Now here specifically 1 is mentioned, but it can be anything. So in general, what I can do is I can just simply write capital A. Yes, Lenroy, what happened? Lenroy, you raised your hand. You have any doubt? Please unmute yourself. Or send it in the chat box if you have any doubt. Okay, okay, fine, no problem, no problem. Prince is asking attendance. No, attendance is left. I'll take in between so that you all sit throughout. Okay. Just okay. Yeah. So students, as I was saying that, just one. Okay, as I was saying, so this amplitude that is there, okay, this maximum amplitude. So here for this particular wave, they have written as +1 and -1. So I can write it in general as capital A or A, simply A. A stands for amplitude because it is above. I hope you all understand the quadrants, the plus minus why it is there. I hope you all understand that. If I think of this, or let me see if there is any other diagram over here. Okay, there's no other diagram. So let me explain you all in this diagram itself. For example, if this is my x-axis and this is my y-axis, okay, and my sine wave starting from origin is propagating along x-axis, okay, fine. Here on y-axis, the amplitude above 0 it is +1, below it is -1, okay, fine, which can also be written as a and -a. Okay, fine. So using all these, I can say standard conditions, what they do is they develop, see, this entire derivation is there over your students. Again, no need to concentrate on the derivation part. I'll simply skip to the final equation that is there. Okay, so you all can see over here, this particular equation. This equation you all can see over here. This is nothing but the wave equation. Okay, fine. You all can see A sine kx plus minus omega t. Isn't this equation similar to what we have seen just now for Ey and Bz? As Saurav asked, instead of E naught, can I write A? Yes, you can. But the thing is that, see, E naught means amplitude, A also means amplitude. But as I said, those equations have been written referring to this equation. So what will you all do for B equation then? Yes or no? You all cannot write A on both the sides, on both the equations. मिस फाइल लिखना जरूरी है क्या? ओके प्रिंस, ओके नो प्रॉब्लम प्रिंस, नो प्रॉब्लम. सौरभ, मिस फाइल लिखना जरूरी है क्या? फाइल, सौरभ वेट बेटा, लेट मी जस्ट गेट टू दैट पार्ट फर्स्ट. प्लीज कॉन्सेंट्रेट ऑन व्हाट आई एम एक्सप्लेनिंग. आई विल एक्सप्लेन दैट 5 part. Wait, hold on. Okay, fine. So students, as I was saying, you cannot write A over there. Like the equations that we are studying, Ey and Bz, वहां पर A मत लिखना because A is general amplitude. We know that for electric field we denote amplitude by E naught, so you all have to write E naught only. For magnetic field we denote amplitude by B naught, so you all have to write B naught only. It's not like in both the equations you all can write A. No, that is incorrect. Okay, as I said, this is like the general, this is the standard equation. Referring to this, they have written for Ey and Bz. Okay, you all can note this down, students. The one that I've marked just now, the blue marking that I've done, just note down that much part. No need to look at anything else. Okay, you all can just note it down. You all can note it down near those equations only, the equations that are there in your textbook, Ey and Bz equations. So उसके side में कहीं पे तुम लोग लिख के रख सकते हो ये. Okay, so again students, here A stands for amplitude, sine is my function, kx. See students, again the same thing, k is nothing but my propagation constant given by 2 pi upon lambda. X is because the wave is propagating along x-axis. Okay, and then omega is nothing but the angular frequency. Okay, fine, and T stands for time. Now what is this plus minus? I'll tell you all what is this plus minus is, because in textbook both the equations had only plus sign, but here in the general form there is plus also and minus also. When to use plus and when to use minus, it is very simple students. Okay, you all simply read, see what is written over here. Yes, Saurav, correct, positive x direction, very good. Okay, fine, so I am not sure how to shift the page. Okay, fine, so you all can see students here, the minus sign is for wave moving in the positive x direction. Okay, fine, and the plus sign is for the wave moving in the negative x direction. Okay, so if your wave, I hope you all know this, right? The 4 quadrant system. So we have plus x on the right hand side and minus x axis on the left hand side, right? So if my wave is propagating on the positive x axis, in this equation I will write the minus sign, meaning kx minus omega t. Okay, and if my wave is propagating in the negative side of, that is the minus x axis, here I will write the plus sign, that is kx plus omega t. I hope you all are understanding. Okay, so this is the wave equation. Why plus minus? Minus will come into picture if my wave is moving along positive x axis. plus will come into picture if my wave is moving along minus x-axis. And students, the EM wave that we are discussing, it is propagating along x-axis, meaning it is propagating along positive x-axis only. That is the reason both the equations have minus sign in them. That is kx minus omega t. Okay, fine. Everyone, please tell me if you all understood this standard equation and how referring to this we wrote Ey and Bz. Please let me know if you all understood.
Yes,
Yes,
miss.
miss.
Yes.
Yes, miss.
Okay, fine. Okay, fine. Okay, good. If you all understood, then very good. Now, this phi part that Saurav was asking. Okay, let me just go a little bit down. Okay, fine. All right. Now, see, students, this in this particular equation, what we can do is we can include a term called phi. Again, students, see, as I have already said, at sometimes you always see notations are repeated. Now, here phi does not mean flux density. Okay, don't get confused. All right. There are notations. See how capital I is used for current as well as intensity. So same notations you all will see at different places. Here phi stands for phase shift. Okay, fine. Yes, initial phase. Okay, phase shift. All right, if any phase shift is happening, again this is little bit in-depth concept which we don't need right now. Okay, fine. All right, so if you include this phase C, it is known as initial phase shift if any phase shift is present. Okay, fine. All right, again students, no, do not concentrate on this part that much because it is not that important as if for now. Only the main equation that I explained to you all, if you all understood that, then well and good. Now, what happens if instead of sine, you all will use cos? Okay, now we all know that there is a relation of 90 minus, right? If it is cos 90 minus theta, it becomes sine. If it is sine 90 minus theta, it becomes cos. Yes or no? So you all know this. So if I look at this equation, this is the same equation, it is just modified. They have added now phase shift also. Okay, if this same equation I write it in terms of cos, you all can see I have marked the cos equation also. You all will see that the equation is kind of same only. Don't concentrate on that plus minus part because now you all know what that signifies. If it is along positive x-axis, then minus will come. If it is along negative x-axis, then plus will come. Okay, so you all know that. But you all can see here in the cos equation, instead of phi, they have written phi dash. Okay, and what is this phi dash indicating? Just a second, it was students, you all can see the entire page, right? On your screen. Is any part cut out? You all can see whatever I'm marking. Please respond.
Yes, miss.
Yes, miss. Okay. Okay, fine. So you all can see this is the sine equation. This is the cos equation where instead of phi, I will write phi dash, and you all can see this phi dash is nothing but phi minus pi by 2. Okay, fine. So when you all will use a different angle, okay, like instead of sine, when you all will use cos, you all have to keep that 90 minus thing also in mind. Okay, fine. So again, students, this is little bit extra information. As I already told, all you all have to know is about this one, this main equation that is there. Where it went? Just one second. This main equation. Okay, fine. So this was little bit about wave equations. All right, fine. Just one second. Okay. So let us continue now. Let us get back to our chapter. I hope you all have understood. Okay, I'm so sorry, students. I'm a little bit sick. All right. Okay. So now let us continue from here. Okay. I hope now you all understood how these equations have come into picture. Now we have few more sums to be discussed. So let us quickly discuss those sums first. Okay. Fine. So see what is written here. Let us read this problem 13.4. Uh, An EM wave of frequency 50 megahertz travels in vacuum along the positive x-axis. Okay, EM wave traveling in vacuum along positive x-axis, and E vector, that is your electric field, at a particular point x and at a particular instant of time t is, okay, so my EM wave is moving along x-axis. Okay, fine. Now we are choosing one point. Okay, we are choosing one point which lies on the electric field. Okay, that point I can label that point as x, and the time at that point is t. What is the value of that point? The value of that point is 9.6 j cap v by m. Okay, fine. All right. Now, students, one more thing. Actually, last time, what I did was I forgot to mention this last time, so you all can make a note of it. That is when we were discussing units. Okay, you all remember I told you all units for the magnetic field and electric field. Yes or no? So magnetic field is nothing but the formula is phi by A. So the unit is Weber per meter square, which is written as Tesla. So that was correct. Okay, fine. Now the formula for E that I gave you all this formula, F by Q. Yes or no? Now see students, according to this formula, what is the unit of electric field? According to this formula, it is obviously Newton per Coulomb, right? Very obvious, force and charge. So according to this F by Q formula, unit of electric field is what? Newton by Coulomb. But we can see everywhere electric field, the unit written is volt by meter, which is correct, and you all have to write volt by meter only. Okay. Why? Because there is one more formula for electric field. Okay, fine. Let me just write it over here. You all can make a note of this thing. Okay, so there is one more formula for electric field, which is given by V by D. Okay, V stands for your voltage and D will stand for the distance. So using this formula, we get the unit volt per meter. Okay, fine. According to the F by Q formula, we get the unit Newton per Coulomb, which is also correct for electric field. But since here in your textbook, everywhere they have used volt per meter for electric field, we'll stick to volt per meter only. It has been derived from this formula. So with this, what we can conclude is, we can come to a conclusion that Newton per Coulomb is equivalent to volt per meter. Okay, it means the same. All right, fine. Everyone, please let me know if you all understood what I explained just now. Yes, students, you all understood or not this unit part that I explained? Okay, what about others? Please respond. Okay, all are
Yes,
sending
miss.
me chat. Okay, fine. All right, so now let's get back to our numerical. So now they have given us a value for the electric field at a certain point, and that value is 9.6 J, 9.6 J cap volt per meter. 9.6 is the value. What is J cap indicating? J cap is indicating that my electric field is along y axis. है ना? I cap is for x, J cap is for y, and K cap is for z axis. Yes or no? My EM wave is moving along x axis. My E vector, they have given the value 9.6 J, so it indicates that E vector is along y axis. Find the magnitude and direction of the B vector at this point x and at an instant of time t. So I have to find the value of B vector and at that certain point, whatever point it is, and its direction. Now finding direction is not that difficult. Yes or no? Wave is moving along x-axis, electric field is along y-axis. Okay, then where will my magnetic field lie? Obviously, which is the axis left, z-axis, right? Yes or no? So you all can, and how to find the value? How will we find the magnitude? Using this relation. This relation was there in one of the characteristics. Actually, this similar kind of sum was there earlier as well. Okay, so we will use this relation. Okay, fine. That is the amplitude of electric field to magnetic field, their ratio is equal to C. So using this relation, I'll obtain the magnitude for B. And as you all can see here, it is written as the wave propagates along x-axis and E is along y-axis, the direction of B will be along z-axis. Okay, fine. And here students, they have not written that point, but to support your answer, what you all can do is, you all can show E cross B. Okay, that is E lies in J cap cross K cap. The answer should be I cap. Okay, yes or no? So this particular point will prove that what you are claiming is correct. Okay, fine. See, I think so it was this sum, similar sum. The second sum that is there, it is similar to the second sum. Okay, only the values are different. Now let's see the next sum. Okay. Now, see students, for an EM wave propagating along Z direction, the magnetic field oscillates, I'm so sorry, for an EM wave propagating along X direction, okay, my wave is propagating on X axis, the magnetic field oscillates along the Z direction, B lies in the Z axis. At a frequency, they have given us some frequency value and has an amplitude of 10 raised to minus 9 Tesla. So students, this amplitude, this is what value? Amplitude of the magnetic field. So this is nothing but B naught. Yes or no? Amplitude of the magnetic field is denoted by B, right? B naught, right? Yes or no? So this is B naught value. What they have asked is, what is the wavelength of the wave? Okay, they have asked us lambda. Write the expression representing the corresponding electric field. Okay, so now students, here those equations are going to come into picture. These two equations that we have seen just now. Okay, fine. So we have to write the equation for the electric field. But first, let us find lambda. Okay, let us see how to find lambda. Now, students, again, this is something that I've explained last time. Lambda is nothing but C by F, where F stands for frequency. Students, for frequency, you all can write F, or you all can also write mu as it is written in your textbook. Okay, fine, all right. Just different notations. So you all can see here lambda, they have written C by frequency. We know C is 3 into 10 raised to 8, and from where will I get frequency? It is given in the question. Okay, fine. So if I solve this, I'll get lambda. Okay, wavelength. So that is why the unit is meters. Now next for the equation. Okay, now see, we know that this is the equation. Ey is equal to E naught sine kx minus omega t. Okay, fine students. Now here we cannot simply write this and leave this over here. We have to fill in the values. What all values we are supposed to put? We are supposed to put E naught value, we are supposed to put k value, and we are supposed to put omega value. Because see, x means it is x axis and t stands for time, and sine function is going to be as it is. But all these other notations that are there, they are going to have some values in them. So we have to find those values now. Okay, fine. So just a minute. Okay, fine. So now the first, let's go part by part. Let us see how we will get E naught. Now what is given to us in the question? In the question they have given us B naught. Yes or no? And we know a relation between E naught, or we know a relation between amplitudes of electric field and magnetic field, which is nothing but this. Okay, that is ratio of electric field amplitude to magnetic field is C. So using this relation, I can obtain what? I can obtain E naught. Okay, as simple as that. And now let us see how to find K. K is nothing but propagation constant given by 2 pi by lambda. Do we know lambda? Yes, we know lambda. We have just now found it, right, in the previous step. Okay, fine. And then what is omega? Omega is nothing but 2 pi f or 2 pi mu. Again, I am repeating, mu is notation for frequency. One suggestion, please try to stick to your textbook whenever you all write. So write mu only. But if you all write small f, it is not incorrect, it is correct only. Okay, fine. So now let us see if we can solve these values. Just 1 second. Okay, fine. So let us see in the next step, students. Okay. Now here is, as you all can see here, in both the places, okay, in both the places 2 pi is common. You all can see 2 pi is there at both the places. So what I can do is I can take 2 pi outside as common, right? That is what they have done in the next step. You all can see here 2 pi, it is still inside the sine angle. Okay students, taking out common मतलब हम लोग उसको sine के बाहर नहीं निकाल रहे, सब कुछ sine function के अंदर ही है. Okay, fine. I am just simply taking it outside these two terms. So if I take 2 pi common, inside I am left with x by lambda and mu t. Yes or no? X is going to be as it is, students, and t is also going to be as it is. But I know the value for lambda and I know the value for mu. Mu is nothing but my frequency. So I'll substitute the values, okay? You all can see here this 10 raised to minus 2 will go above and become 10 raised to plus 2, which is nothing but 100. And frequency, it is going to be as it is. And here students, see here they have done one mistake, that is you all are not supposed to write E naught. You all are supposed to write the value that you all obtained. Okay, this value that you all obtained here, where it is, yeah, so this value that you all got, 0.3. So you all are supposed to write 0.3 instead of E naught, and that is going to be your final electric field equation. Okay, you all can star mark this numerical because this numerical is very important and easy at the same time if you all understand what is happening. And everyone, please let me know if you all understood this fifth sum.
Yes.
Yes.
Yes, miss.
Yes, miss.
Yes, miss.
Okay, fine. Okay, if you all understood, then well and good. Okay, now let us see the last sum that is there. Okay, the magnetic field of an EM wave traveling along x-axis, of an EM wave that is traveling along x-axis. The EM wave is traveling along x-axis, students. Okay, and the magnetic field, they have given us equation. You all can see this part. Now please concentrate on this part. Okay, the K cap stands for that it is along Z axis. K cap is indicating the axis of my B vector. And let's see the remaining part. You all can see this remaining part is little bit similar to something. It is little bit similar to the equation, that is B naught sine omega t minus this thing. Okay, fine. Or here what they have done is they have, why they have reversed the equation? Okay. Okay, fine. Wait, let us see what is written in the entire question first. Here, B is in Tesla, T is in second. Okay, again, capital T here is Tesla, that is the unit of my magnetic field. Small t stands for time. Okay, T is in seconds and X is in meter. Calculate the peak value of electric force. Okay, peak value of electric force acting on a particle of charge 5 microcoulomb traveling with a velocity of 5 into 10 raised to 5 meters per second along y-axis. Okay, so see, my wave is on x-axis, my magnetic field is on z-axis. So obviously my electric field is going to be where? It is going to be on y-axis. That is very obvious. Okay, fine. What they have asked us is that let us read the find part again. Calculate the peak value of the electric force acting on a particle of charge 5 microcoulomb. Okay, fine. And with a velocity along the, okay, fine. So let me just quickly see the solution that is there.